All right, good afternoon, everyone. Thanks for coming to today's session. Super excited to be here. My name is Ray Zhu. I'm a product manager from the AWS RoboMaker team. And today, presenting with me is Gabriel Lopes. He's a principal scientist from Robotics system, one of my favorite RoboMaker customers. So before I get started, how many of you guys, if you can, for a quick show of hands, how many of you guys have heard of or used AWS RoboMaker before? Okay, quite a bit. Cool, awesome. And how many of you guys are robotics developers or develop robotics applications today? Quite a few. And how many of you guys plan to using robotics applications or develop robotics applications in the future for your company or business? Great, awesome. We have, thank you. We have a pretty good mix of audience. So for today's agenda, I'll first spend some time to tell you a little bit about the AWS RoboMaker service, the original inspiration for us to build the service, why we did it, what the service does, how they can help you today or in the future as you build robotics applications. Then I'll turn the stage over to Gabriel to share with you guys Robotics system story of using AWS RoboMaker to accelerate the development and also put some intelligence into this fairly awesome robotic walker. So, what is really a robot? Because depending on the people that you speak to, people have different understanding of robots. They might think of a drone, a humanoid robot, an under-the-water robot, a robotic arm, self-driving cars. From our perspective, from AWS RoboMaker's perspective, all of these examples here are robots to us. We think of robot as anything that can sense the surrounding environments and using the signal to do computation and make a decision, then eventually actuate and react to the surrounding environments. Really, the inspiration for the AWS RoboMaker service started with some of these internal applications at Amazon where we use robotics technologies. We've got the famous orange Kiva robot that moves inventory in our fulfillment centers. We've got this primary drones that delivers packages. And recently, we've also unveiled the Scout project, which is an autonomous delivery robot that handles last mile package delivery. So for AWS RoboMaker, we started a project as we speak to these internal robotics teams who are working on a robotics project. Then we also went out to other companies out there who are doing robotics projects. And they all face similar problems throughout the entire development life cycle of a robotics application. They all go through something looks like this. They have to first pick a robotics software framework to develop their applications on so that they can leverage all the ecosystem of robotics functionalities already exist out there in the market. Then they have to develop the application code on top of it, which is a software that eventually controls the sensing and movement of the physical robot. Then they have to test it and simulate. In robotics, simulation is a fairly common and efficient testing mechanism for you to test the different functionalities and capability of a single robot or a fleet of robots using a virtual environments without having the physical hardware and have the constraints of physical environments. Then lastly, once the application is developed, you have to deploy onto a fleet of robots over the year and update them over time. So throughout that entire process, we've heard very common pain points and issues that has nothing to do with the core robotics application that's taken away a lot of development cycle and a resource from these different groups and companies. So we thought about it and say, that's what AWS is good at. Let's solve these common problems for all these different robotics developers so that they can focus on developing their intelligence and applications, but not getting into these common problems throughout the entire dev life cycle. So the first thing we looked at is ROS. It's called a robot operating system. It's the most popular open source software framework for people to build robotics applications on top. It started about 10 years ago by an organization called Willow Garage, started for research and academic purposes, then gradually got adopted by commercial companies building commercial applications on top. Then we spoke to a lot of companies doing robotics program. A common pattern is they all use ROS, but they don't like ROS that much for commercial applications. The reason is because it started with research programs, so there's a huge and broad ecosystem of functionalities you can pick and choose. But for certain commercial grade characteristics like security, reliability, or real-time consistency, all of these things are not built in mind when ROS project got started. So a lot of these companies, either they do prototyping on ROS, then they have to fix ROS, spending a lot of resource on security reliability, or worse, rebuild the entire stack after prototyping on ROS from the ground up. So we thought about that's a pretty painful process that every single company have to go through. So we want to fix that. We want to help the community to fix that. So for a lot of the commercial industrial applications, they can build on ROS and keep using ROS in production workloads while keep maintaining the vibrant ecosystem of the ROS project. So then we started working with Open Robotics Foundation, which is the organization that maintains the ROS project, on the latest version of ROS called ROS 2. Although it's just one version ahead of ROS, but it's a fundamentally redesigned architecture from the ground up. It's using the open source data distribution service standards, which is basically a message passing mechanism. It's a standard interface so that you can pick and choose different type of DDS implementations. You can use open source options like fast RTPS or open slice. You can also use in commercial grade offerings like RTI. So depending on the type of applications you want to build, whether that's a research, you want to have open source version, whether that's for commercial grade applications, you can have a secure and reliable message passing mechanism underneath. It's open source, similar to ROS 1. It's under the Apache 2.0 license, so that every company can use that to build the commercial applications without too much constraint. And as I mentioned, we've been working with Open Robotics Foundation along with a number of industry companies, including Intel, Bosch, Microsoft, LG, Toyota. And we were super excited, like 2 weeks ago, the latest release of ROS 2 called Dash-in Release was announced. And that was the first ever long-term support release of ROS 2. Long-term support meaning the API will be supported and maintain backwards compatibility for 2 years. And in ROS project, that's a huge signal that we think it's a solid version that people can take a long-term project and build commercial applications on top. We will continue to work with Open Robotics along with these industrial partners to really advance the ROS 2 project so that any company for any type of commercial applications, you can build prototype on ROS and you can take that application into production without redoing anything. So other than the ROS project, along that, if you recall that entire dev life cycle, there are many other pain points that everybody's going through. It's pretty hard to operate and integrate intelligent capabilities into a robot because robotics developers, they are often experts on hardware, embedded systems, robotics functionalities, but not necessarily expert in ML AI. It takes time to set up a dev environment. And for running simulation, people love the capability to do tests without a physical robot, without a physical environment. But setting up the software, managing the infrastructure, and scale them, particularly when you have to run hundreds of them, that's pretty painful. Then lastly, for over-the-air updates of the software, either you have to build the solution yourself or have to integrate it with a third-party solution. So we look at across these entire dev life cycle and figure out all these common pain points. And that's why we did AWS RoboMaker, which was a service we announced at AWS re:Invent conference last November. It's a service that aims to solve all these common problems throughout the entire dev life cycle so that as a robotics developer, as a quality engineer who's doing robotics testing, as a system engineer who's managing large-scale robotics fleets, they have all these tools and a single unified platform to do all these type of operations and development. RoboMaker has these 4 independent yet integrated capabilities. So all of these different capabilities are integrated. You can use them as a single platform, but at the same time, you can pick and choose for the ones that matters the most to your current operation cycle and dev cycle. First, we offer a dev environment in the cloud with all the necessary software packages and toolings pre-installed. You can access the dev environment through a web browser. So instead of spending hours setting up the environment, you can now start development right away. We offer cloud extensions for ROS, where at AWS, we have a number of hosted services in the cloud from machine learning to data ingestion, data analytics. The idea here is we want to bring all of the power of all of these services to the hands of ROS developers and make that a bit easier with an easier and familiar interface for these robotics developers to integrate these service capabilities into their ROS applications. Then we run simulation as a service. So we take care of all the infrastructure management, scalability, reliability, availability behind the scene for the simulation infrastructure, so that as a developer or a quality engineer, you just need to give us the simulated application along with the scene, and we run that at scale for you. Then last, fleet management, we provide over-the-air updates capability. Once the application is done and tested in simulation, you can push the application onto a large number of robots managed under different fleets. I will show you guys these capabilities a little bit later through a live demo so that you can get a concrete feeling about how it looks like. First, I talked about dev environment, takes away all the configuration, environmental setup, particularly useful for somebody who just wants to get hands dirty, start trying ROS development very quickly. It's being adopted largely through universities, research programs, along with the workshops. If you've attended a RoboMaker workshop on Monday night, you've probably already experienced using the Cloud IDE. But as I mentioned, it's just one option that you can choose and use. For developers who still prefer to develop locally on their desktop, they can use the rest of the RoboMaker capabilities independently. So this is how the service works for the Cloud IDE. It's built on top of AWS service called Cloud9. Essentially, it's a web interface, a web-based IDE tooling that's backed by a Amazon EC2 instance along with EBS storage volume. Depending on your type of development workloads and use case, you can pick and choose the right instance size, whether you want a lot of CPU or memory, what's the storage requirement, do you want SSD or non-SSD? You can pick and choose these different configurations, then through a single click of a button, we'll set up that army, provision that resource for you. ROS, Gazebo, along with the build tools that's pre-installed into the environment, and we provided many options for you to use other RoboMaker capabilities like simulation from the same interface, which I will show you a little bit later on. From that particular IDE, you will typically develop your robotics applications on two different workspaces. First is a robot workspace, and the software code in there is the software that will eventually deploy onto the physical robot. And in RoboMaker, that's the concept we call a robot application, which is what you simulate and eventually do the deployment. The simulation workspace contains a software code that will allow the robot to be simulated in a 3D virtual environment. And the simulation workspace contains the 3D scenes, along with the plugins that's used for the robot application to control the virtual robot in the simulated scene. And eventually, as I mentioned, these different applications will be being built and uploaded and created in RoboMaker service, and you can deploy the robot application onto the physical device and use the robot application and a simulation application to run a simulation job to see how it works in the virtual environment, which I will show you guys how that looks like. Then we have cloud extension. As I mentioned at AWS, we have these broad selection of different ML and data ingestion services that is pretty much relevant to a lot of robotics applications. And what we want to do is really bring the capability of these different services to the hands of robotics developers. Today, we provide these 6 different cloud extensions. We've got Amazon, Poly, and Lex, and combine these 2 ML servers, you can basically build voice interaction capabilities into your robot, and you can actually put these type of functions on Raspberry Pi because all the heavy computing workloads happens in the cloud. We have Amazon Kinesis video stream for video data and sensor data ingestion. And if we pair up that with Amazon recognition, then you can do interesting things like object detection or facial recognition. Then lastly, we've got CloudWatch metrics and logs for you to offload telemetry data, metric data, text log from the physical device into the cloud so that you can do monitoring, alerting, and analytics on top of these data. Here, I just want to give an example of how it looks like when you integrate the cloud extension into your ROS application. So ROS is a pub/sub system. It has a concept of a topic and a concept of a ROS node. A topic is basically a message queue where you will publish the message into. A node can be a subscriber and can be a publisher where you can subscribe and receive the message from the topic or post message into the topic. What we did is we wrapped the CloudWatch service capability as a ROS node. So for a developer, you just need to download that particular package and have that particular CloudWatch node get subscribed into a particular topic. So as you post the message into that particular topic, that node will pick up these metric data or log data and forward that into AWS CloudWatch service automatically and handles all the failure retry and security authentication and connection creation. There are two ways you can do authentication here. One way is the typical way where you just put the credentials in the form of 2 keys locally on the robot. It'll use these credentials to create a connection with the AWS service before it sends over the data. And second way, which I really think is the right way to do that, is it's integrated with AWS IAM security capability, where you can create what we call an IAM role. So what the IAM role does is it gives the robot the permission to request a temporary credential and to send data into a particular service. So in that case, that role, these permission can be managed from the cloud side. So once you ship the robot, in any case, if you want to change the permission, you want to revoke access from a particular robot, you can just do that operation on the cloud side by changing that IAM role versus without having to kind of update the software on the robot. So that's really the right way to manage these type of permission and access control for a large scale of robot fleet. Then we did a little bit more than just provide these different extensions. Actually, for all of these extensions, we've built a few different sample applications to demonstrate how you can integrate these type of cloud extensions, these functionalities into a real robot application. And for all of these sample applications, we provide a one-click experience that you can actually run these applications in a RoboMaker simulation environment. So if you go to AWS RoboMaker Console today, you can actually see how it works, which I will show you guys later on. And for all of these sample applications, it's compatible with a robotic dev kit called TurtleBot. You can actually deploy these sample applications onto a physical robot and see how they work in the real world. They're really fun to play with. Then I talked about simulation. Essentially, the idea is we want to provide a service that manages popular simulation engines and tooling so that as a developer, you can just focus on application development. And once you have your robot application and simulation application, you can just offload these 2 applications in RoboMaker. What we do is we'll take these different applications along with the managed service capabilities. We will run that behind the scene on an EC2 instance using container technology to isolate the process and also for security purpose. But you don't really see all that instance or container. You just give us the application, then we will allow you to interact with the simulation. So on the left-hand side, you can see a list of out-of-the-box toolings that's fairly popular in the ROS ecosystem. Gazebo Client, RQT, RViz, Command Terminal. We will manage and launch these different toolings automatically for you. You can interact with the simulation through these tools by launching these applications from the web browser. On the right-hand side, because of the cloud extension integration, you can actually interact with these AWS services from ML service to metric and logging service from the simulation. They become really handy when you want to run, let's say, 50 or 100 or 300 simulations at the same time. In these cases, the developer or the testing engineer, you no longer stare at, because it's not possible for you to stare at 300 running simulations and figure out what's going on. What you typically do is you can define a key metric, for example, collision. In these 300 simulations, is my robot colliding with any object as it's moving around? And you can emit these collision metrics and logs into CloudWatch. So you can just say 300 simulations, run that for 5 hours. 5 hours later, you go to CloudWatch metrics and see which particular run caused a particular collision, and then you can dive into the logs or rerun that particular simulation for troubleshooting. So these type of features is really handy for things like large-scale testing and regression testing workloads. Now I want to quickly show you how these things look like from the RoboMaker console and how these things all work together. Okay. This is the RoboMaker console. If you look at the left nav side, you can see at the top, these are 3 different panels for our development capabilities. First, we've got a dev environment, which is a Cloud9 environment where you can write your application code on. Here, if you try to create an environment, it'll let you pick, as I mentioned, different size of EC2 instance. You can pick a small instance or CPU computing intensive or memory intensive instances. You can configure a network setting for the instance to interact with other AWS resources and anything outside of the internet. Here, I've already pre-created an environment. And when you launch this particular environment, this is how it looks like. It's a fairly standard IDE interface. You just access the environment through a browser. ROS and all the building bundling tools is pre-installing that environment, so you can start writing your application right away. From the menu, you can actually download the sample applications I mentioned and also these cloud extension packages I mentioned. Here you can look at from the left nav. I've downloaded this person detection sample applications. Under that, it's got a robot workspace, simulation workspace. If you recall, robot workspace is the code that are eventually deployed onto the physical robot. In simulation workspace, it includes the 3D models and the plugins to control the robot to move in a simulated environment. Then we also have a simulation menu. Once I connect with the live simulation, you can actually visualize the simulation from this interface so that you can actually iterate on your code. You can update your code, build, bundle, update the simulation, and view the results through that entire iterative development life cycle all through this single interface. Then as you finish the deployment and build the application and bundle the application from the command tool, you will upload these binary files into a Amazon S3 bucket. Then from the Robomaker console, you can create a robot application and simulation application. And that's essentially a pointer over to a binary file in an S3 bucket. And we'll keep tracking different versions so that as you iterate through your applications, we will track different versions of your application. You can roll back, you can move forward, you can have your testing versions, you can have your production versions. Then the interesting part is what I really want to show you guys is a simulation. So as I mentioned, if you go to RoboMaker console today, we offer these 6 different simulations. You can just pick any of these to play with that. We've got a voice command simulation where you can use voice command to control the movement of the robot. We have navigation and person detection. There's autonomous turtlebot navigating a living room. And we actually have images of people hanging on the wall. As the robot detects the person, it'll stream the video into Kinesis and using recognition to pick out the person hanging on the wall. These are just very fun examples that you can build on top and have some fairly interesting simulation running on RoboMaker. So here I've created a sample simulation job, which is the CloudWatch one. So these are the 4 GUI tools that I mentioned from the previous slide. In this case, I'm just giving a robot application, a simulation application, and create a job out of it. I don't see any EC2 instance or network configurations or storage volume. It just runs it for me. And once the job is running, I can pick and choose these different tools that I can interact with. So this is kind of a 3D environment that's building to my simulation application. I don't know if you guys can see. On the left-hand side, you see this gray dot. It's actually a simulated turtlebot that's navigating in this room space. And you can use different toolings. For example, this RQT tool. What I'm doing here is I'm using RQT tool to visualize the camera sensor from the robot. So basically, this view here is what this robot is seeing as it navigates through the room. And this video is being streamed into Kinesis video stream. So on the cloud side, you can do interesting things like record the video or hook up with recognition to pick out a particular object and then send the object back to the robot for object detection or facial recognition. And there's also an interesting tool which shows you how the robot is navigating. So it's got a very basic autonomous navigation stack running in the robot right now. So you can actually see from the top-down view, as the robot navigates through, you can see, oops. Yeah, it's a little hard to control through a touchpad. Yeah. So basically what you're seeing is this highlighted area is what the robot is seeing. That's basically what the sensor data, the LiDAR sensor, are able to reach out. And you can see this particular line. So the end of the line is basically the go. So the robot says, I want to navigate towards that direction. And as it moves around, it keeps adjusting the optimal path to get there, and it'll detect the surrounding obstacles and try to avoid that. And all that code is open source, and in the sample application, as I mentioned, if you want to buy a TotalBot kit, you can actually deploy that application onto a physical kit and see how it works in the real environment. You can optimize the navigation function and play with it. Now, for this particular application, actually, it's also integrated with a CloudWatch extension that I mentioned. So as this robot is simulated in the virtual environment, it's emitting different metrics into Amazon CloudWatch. And you can imagine when you test that in a simulation environment to make sure the metric emits properly, as you deploy the application onto the physical robot, it'll emit the same metric and logging data into CloudWatch as well. So in this case, the metric gets emitted from the simulation as the job is running. You can see in the application, we are emitting linear speed. You can plot a view, how the linear speed changes. You can see what's my distance to the nearest obstacle. So as the LiDAR sensor is scanning through the surrounding, it keeps tracking what's the closest distance, what's the distance to the closest obstacle. And all that data gets streamed back to the cloud so that you can keep them, analyze them for the long term. You also got a CPU usage, memory usage. I think the purpose of this sample application is really want to demonstrate how you can use these different AWS services to enable your robot to do interesting things, intelligent things, and also monitor the metrics and logging data as you operate the robot at scale. So this is how the console looked like. Now, there's one more fairly unique value I think is super interesting when you run simulation in the cloud is theoretically we have the infinite amount of resources running in the cloud, which means you can run hundreds or even thousands of simulations concurrently in the cloud, which you couldn't really quite do if you are doing development work or testing locally. This is one of the very interesting examples. I don't know how many of you guys heard of the AWS Deep Racer project, or awesome, quite a bit of you. So Deep Racer is a racing kind of competition where it allows the user to use a reinforcement learning model to train the model in a Amazon SageMaker service so that eventually you'll deploy the model onto a physical racing car, and we have these racing competitions all year round. So the way you do the training is Deep Racer is actually using RoboMaker's simulation engine. So any of you guys have used Deep Racer, then you're already a RoboMaker customer. You've already used RoboMaker simulation. So the way it works is, the beauty of this is, number one, you can run a number of different RoboMaker simulations and have the car driving a virtual environment and keep feeding the data, training data into SageMaker to train the single RL model. So you can train the model much faster. And second is, for each of these simulations, you can run faster than real time. So you can run 2x, 3x, which means for every minute in the real world, you've trained a single simulation for already 3 minutes. So that's a really effective way, an interesting use case to use a simulated environment to train a machine learning model running Amazon SageMaker. Then lastly, I want to talk about fleet management. That's really for when you've developed and tested your application. Now you have a physical fleet of robots. How do you manage the fleet? How do you do over-the-air updates over time? So we provide this fleet management capability, which is integrated with the AWS IoT service called Greengrass, which is AWS Edge service that you can do local compute, local inference, local ML model, over-the-air updates. So the way it works is you will first create an entity in RoboMaker called a robot. And when you create the entity, it'll generate an agent, Greengrass agent, along with a certificate that you will install on your physical robot. And once you've done that, it'll get connected and registered with the RoboMaker service. And then you can organize robot by different fleets. You can have a better testing fleet so that you can deploy application onto the testing fleet before you go production. And once you launch or initiate a deployment job from RoboMaker, it'll send a deployment message queue into AWS IoT, something we call a device shadow. And all of the robot that gets registered within that fleet will get pushed down a message saying you gotta have to deploy. Then these robots will go to the S3 bucket where you're storing the latest robot application to fetch the application and then launch the new application as needed. And throughout that entire process, the status will get updated over to RoboMaker so that you can view, as the deployment job is going on, what's the status of each robot, what's the progress on each of the fleet. At a fleet level, we provided two different configurations for you to control how you want to run the deployment. The first one is the concurrent deployment percentage. So that makes sure that you don't want to when you push out a new application, you don't want to push the application into the entire fleet. You can choose to deploy them in small batches to make sure that in case anything goes wrong, you have a controlled and limited blast radius in that manner. And second thing is a failure threshold. For example, if you say, I have a 10% failure threshold as my tolerant level, then anytime when we push an application onto a fleet of robots, if more than 10% of the robots have a failed status, we will automatically terminate that deployment. That's, again, to make sure that you have a fairly controlled blast radius as you push the updated application onto your fleet of robots. So that's kind of a quick overview for the RoboMaker service. Now, that's the cool part. Let me introduce and welcome Gabriel to the stage to tell you guys about the story with Leah and Robot Care System.
Thank you.
Thank you.
Well, we're a fairly small company in the Netherlands, and the mission of our company is to improve the quality of life by means of robotics. And to explain exactly what this means, I want to show you a video. This is Case. Case is retired, and he's a grandfather. And very recently, he was diagnosed with Parkinson's disease. And this was catastrophic for him. He lost his mobility, he lost his independence, he's continuously relying on his wife, and it really, really changes the life of a person. Well, we invited Case to participate in a pilot program with our robot. We gave him some instructions, and very quickly, Case got up and just walked. This was really fantastic. He could just feel comfortable, he was stable, and the robot was using lots of technologies to allow him to feel this confidence in this stability. This is a robot which is designed with lots of sensors to make it very safe. It monitors the posture of the user, and it's really providing confidence. So what is Leah? Leah is the Lean Empowering System. It's designed to be very, very interactive, very user-friendly. Users don't need to learn anything. They just pick it up and walk. It has sensors on the handlebars, so the moment you touch it, it will walk with you. And it's also a hidden robot. It doesn't look like a robot. We actually don't call it a robot, but it's a fully autonomous robot. You can send it to some other location of your home when you're done using it, and we give a button to the user so that when they press the button, the robot will find where the user is in the house or in the hospital. It's also a medical Class A certified robot, which means that it can be used in a hospital and a care center. And it was really designed from the perspective of the user. Everything that you see here was the result of pilot studies that we did with a number of patients to understand what are their real needs. But I also want to tell you a bit about the technology behind it. So to provide all this safety, we had to install a lot of sensors. So this robot has 72 sensors. It has a LiDAR, a 3D camera, a normal RGB camera. It has time-of-flight sensors, ultrasonic sensors, infrared sensors. It has capacitive sensors. It has a huge array of sensors. And we use these sensors for navigation, for autonomous navigation, but for also understanding the intention of the user. Well, all these sensors, what they provide is redundancy. You can imagine that when you're moving around in a cluttered environment in a home, some sensors will pick up some obstacles, but other sensors will not. For example, if you have a glass door, the time-of-flight sensors will not see it, but the ultrasonic sensors will. So if you combine all these sensors, you really achieve redundancy, and you maintain the safety of the user. Also, we use the low-end CPU, so we don't have much computation capability. But because of that, we have to really optimize the software. And we're using ROS, the open source robotic operative system. Well, on top of ROS, we built something that we call ROLL, which is the robotics language that I will tell you in a minute. We've also integrated cloud support so that You can do video calling with the robot, or you can also upload data of the usage of the robot to a physician so that they can monitor the progress of the patient. So it's really designed for the user. It's really trying to fulfill a gap of people in need. I want to tell you a little bit about the software that we're using. So we build on top of ROS, but we had to create something to speed up our development. So we started automating the way we code. Now, this is a bit interesting because usually you use software to do automation. In this case, we're actually automating the process of creating software. And we do this by creating this concept of abstraction languages. And abstraction languages are simple languages that focus really on the problem that you want to solve, and then we use them to generate code. And in particular, we generate a ROS C++ code or Python code. We can also generate ROS1 or ROS2 code. And given that the information is there on these languages, you can also generate dashboards and GUIs automatically so that you can use these interfaces to debug and visualize what's happening to these nodes. So really, ROL, or this robotics language, is a tool that allows you to create your own languages. It's a transparent compiler. You can see how the whole process from a parsing to abstract syntax tree is happening. And it's open source. We liked it so much, and it was so useful for the development of this robot that we decided, let's just give this tool to everybody. And most importantly, for the investors in the room, it really saves time in development and maintenance. You start working with abstraction languages, you don't need to work with the details of C++, for example. Well, if you're interested, there's the GitHub repository. You can take a look. And if we're looking for partners to contribute to this and to use, so please let us know. But there's only so much we can do ourselves. We have a limited CPU. We have limited resources to write software. If we only do this, we can't go very far. And that's where AWS RoboMaker comes in. What AWS RoboMaker provides is a collection of tools that we would never be able to make ourselves. In particular, Amazon Lex and Poly allows us to add voice interaction to this robot. With Amazon recognition, we can recognize the face of the user as it approaches the robot, and we can automatically configure the robot for that particular user. The speed limit, the parent inertia, and the contact information that shows up on the tablet. And also allows us to create our own models for machine learning, that we can push even the performance of the robot even further. So we started using RoboMaker to integrate with Lex and Poly. Also, when you have multiple robots in the field, it's very important that you should be able to monitor these robots to make sure that everything is all right. And this is what fleet management through CloudWatch provides us, so we can remotely monitor everything. It's, of course, very important to do updates over the air so that we can continuously improve the software. And one very interesting thing that Amazon can also provide us is all this IoT infrastructure, which allows us to connect to specific topics, these ROS topics, and send this information in real time to some dashboard that we can then visualize these topics in real time. And you can see exactly what the robot is feeling. So we do that through this MQTT protocol. There's a bridge from ROS to MQTT, which is the IoT protocol. Then we send this to the cloud. It goes through a Lambda function, goes through the Amazon API gateway, which basically implements a WebSocket server. And then the websites, how many websites you have open, they will connect to this WebSocket server and will release the data in real time. So all of these tools really open a new world for robotics developers. So many things you cannot do by yourself. You're all of a sudden exposed to this whole new world. So for us, really the big important thing that people were requesting was voice interaction. Because as you can imagine, users that are working with this robot, it's very difficult for them to think in terms of technology. They're potentially tired. They don't want to deal with the graphical user interfaces and all sorts of things. So if you provide them voice interface, you can just tell the robot, Leah, let's dance. What would you like to dance? Let's dance the Roomba. So all these kinds of functionalities are much simpler to do if you have voice interaction. Well, when people ask us, can you build voice interaction? We always said, It's very, very hard for us to do this. We would take years to get to that level. We're a small company. And if we try to license this, it's also very expensive, so it's not a priority. And then comes along RoboMaker. All of a sudden, and this is true, in literally hours, we integrated Lex and Poly, and we were able to control the robot by voice. And then you pay as you use. So it's really a perfect model that allows you to experiment, to exploit. And then when you scale up, the payment also scales up, but then you're in good shape, so it's OK. Well, I want to finish and just show you a little movie. And I will have to. Yeah. But before I start the movie, I just want to say something. So being a scientist, an engineer, developer is really exciting. You get to play with really fun toys and write really fun code and do some very special mathematics. So it's really privileged to be in this position. But if you can do this and at the same time help people and solve some of the societal problems, then you're really advancing civilization. So to end, I would just like to show you a bit of a preview of our next generation of our robot. And it goes a bit like this. Oh, the sound? No, sorry.
What would you like to dance?
I'd like to dance the samba.
Okay, let's dance the samba.
Okay, here we go.
Baila, baila conmigo, baila, baila mi amor, baila y mexe umbigo, y así es que se baila mejor. Baila, baila conmigo, baila, baila mi amor, baila y mexe umbigo, y así es que se baila mejor. Dame chipito.
Thank you very much. Oh.
All right, thank you, Gabriel. Before we wrap up, I just want to do a quick recap about what RoboMaker is. It's really a set of different tools and capabilities and services that's intended to help robotics developers, testing engineers, and system engineers to develop, test their robotics applications, deploy the applications onto a fleet of physical robots, then manage that fleet of robots over time. In addition to the amazing robot care system, the Leah robot, since we launched the service, there's been a number of different customers leveraging our service capability to build robots. What's exciting to see here is, in addition to robotics companies, you also see enterprise companies who's trying to leverage robotics in their business. So super excited to see that. Then lastly, we know the roots of ROS, a lot of robotics research and development comes out of universities, so we want to return that amazing technology the community has developed back. So what we've been doing is we launched a RoboMaker education program where we are supporting universities and research institutions with free RoboMaker service credits and usage, along with some hardware kit for the students and researchers to leverage robotics in their courses and leverage RoboMaker in their teaching and research. So if there are students or professors or researchers in the audience, if you're interested in learning more about this program, here's my contact, and you can reach out to me. We still have a bit of time. I think we can take some live questions from the audience. And if you'd rather ask the question later on, we'll probably stay around a little bit afterwards. But if you have any question you want to ask right now, please go for it. Other than that, thank you guys for coming, and I hope you enjoy the rest of the conference. Thank you.